Okay, that's ready.
Nah, can you like click on the start one?
This one?
No, that's Kenya.
Shut Kenya down.
Just get rid of Kenya.
Okay, whenever.
Yeah.
Oh,
No reservations. We good?
Mm-hmm.
Yeah.
you actually have 15 minutes, so it's good. Yeah.
That's it. When I was a child and I was learning to ride my first bike, my parents would all just like let me go on the bike and ride, but they soon realized that's not the best solution. They had to put a lot of band-aids on my knees and my head because I crash a lot. Later on they figured out a helmet is actually a lot better. That's what we're providing today. With Eccc, we're providing a helmet, not just a band-aid solution for the problem that is climate change. We're the Faces Consulting. I'm Nick. I'm here with Manpreet, Megan, and Colton, and thank you for having us in Montreal today. So we've looked at some of the issues that you've identified for us, and the major issues we've seen right now are basically the symptoms of a problem. So that's ice storms, extreme cold, extreme heat, droughts, floods, and flora and fauna death. So this all leads to a huge problems for humankind, and we could be fixing one of these problems, but we do believe that this is not an underlying problem. The problem we have right now, there's an increase in average temperatures and temperature fluctuations on Earth caused by human-emitted greenhouse gases. So we have to decrease those greenhouse gases to make sure those temperature fluctuations go down. So what we're doing today, we'll have an impactful solution that will help the future generations of humanity by reducing the greenhouse gas emissions. And we have a tangible solution. People can see the benefit right away, and it is realizable and scalable, and it's innovative. The research about this has only been done over the last couple of years, and it's really groundbreaking. And we're attacking the issue at its root cause, not looking at the symptoms of that main issue. So currently, looking at the Paris Protocol and the agreements that they've had, even if we do the promises done so far, the Earth's going to keep warming up, and this catastrophes are keep going to happen. And what we've seen in the trends in the industry right now, there's been a move away from the greenhouse gas emissions, going into electric cars, trying to stay away from those, from carbon dioxide emissions. But the current efforts are not enough. So when we've seen that the main part of this is cars. They contribute over 25% of these emissions, and they have to be cut down. There is a huge effort for electric vehicles, but it's not going to happen fast. It's going to take a long time, and something has to be done in the meantime to prevent disasters from happening. So we have three possible solutions. First of all is Eccc. It's a proven technology, which Manpreet will go into more detail. It has high impact, and the industry is desperate for change. The car industry wants something to be changed, especially some players like Volkswagen that have been hit with scandals recently. There's also algae cattle feed. But you've seen that there might be a slow phase out of cattle just because the lab-grown beef will be viable and cost-effective by 2020. And there's some entrenched players in the industry like Cargill who won't let us in there, and the farmers will be unwilling to get these additional expenses to produce that beef that's healthy for the environment. And the cloud seeding, there is no proof of concept. There's really high national and international regulations and really high startup costs. If you want to move clouds across the sky, right now it's just impossible to make it cost effective. So what are we doing?
We're clearing the air. So we have decided to focus on the exhaust pipes of automobiles. So as you can see, that is the focus that we thought would have the most impact on the greenhouse gas emissions. And so we are optimizing this exhaust pipe by looking at metal organic frameworks, MOFs. So these are essentially derived from a form of chemistry that links molecular blocks together with these ligand bridges. And in terms of metal organic frameworks, we have metal ions that are in these clusters, and they're connected by those ligands. And in the center of these, in this framework, you have these pores, and that really allows the carbon dioxide to be absorbed in and stored. And so why MOFs are so incredible at absorbing this carbon dioxide and storing it is the fact that they are actually proven to absorb 9 times more CO2 than current methods, and they're the fastest growing field of material science. So this is very current technology that we decided to incorporate in. And in particular, we're looking at MOF 177, as this has proven to be the most effective for carbon dioxide recapturing. So with these MOF granules, we have decided to incorporate this in with a coating that we would apply on the inside of the exhaust pipe tubing. So we'd spray that on the inside so that when the exhaust would pass through, the CO2 in that exhaust would be absorbed and recaptured into this MOF framework. And so some of the design criteria that we looked at is obviously the exhaust temperature is quite high. Actually, MOF is more effective at higher temperatures, so this was definitely something that we thought was beneficial. We also looked at coefficient of friction, the impact resistance, and porosity control. So looking at the fact that when these pores get saturated with the carbon dioxide, what kind of the timeline is for that. So now Colton is going to make sense of the numbers.
So just as Manpreet did allude to, one of the most exciting things about MOF is its implications that we can implement into the market. At a large scale, there's a ton of implications for MOF in terms of decreasing global GHG emissions because it can be applied to so many different materials in industry. We're talking smokestacks, we're talking exhaust pipes. There's a lot of different very feasible applications that this could be implemented into. For our study in particular, we looked at the financial scalability and impact of partnering alongside Volkswagen and looking at improved customer perception of what they've currently done with their vehicles. They've had some troubles in their current industry in regards to really complying to the emissions that they have to meet in their country of Germany and specifically in Europe with their Audi line. And that's something that we thought would be a largely scalable solution at a small starting impact, so you could really see the tangibility of what we could do with MOF. Now the key partners in this case would be the MOF supplier, where we would gather the powder from, the MOF binding supplier that would allow us to bind the powder with the paint coating, and then finally the Volkswagen Group, in order to finally realize that implementable solution and to have a consumer that would work alongside with us to develop feedback and to continually improve on our product. In terms of financial analysis, we did outline some of the net income versus annual revenues in terms of an NPV analysis here, and you can see in the first year in blue, although your net income is rather low, that is due to your high initial cost of just around 488,000 euros, and that cost is so high just because of the initial costs of funding that manufacturing facility and just starting the operation up, where you would realize more gains in your net income in years 2 to 5. That would equate to an entire 5-year NPV of 1.49 million euros, and that will help realize savings of just over 88,000 metric tons of carbon annually with financial sustainability, and that's the key here. That stability that's brought with this plan that we've set out for you is going to allow Volkswagen to realize those kind of impacts within their Volkswagen line. With 10.4 million Volkswagen vehicles sold, we decided to key in on their Audi sales in Europe specifically, and then to focus in on, in particular, their A3 unit. The cost per unit of our exhaust that would be going into these vehicles is just around 111 euros, and now that is dependent on what contract would be realized with Volkswagen and with Audi, for a markup of just around 50%, which is industry standard, to realize 166 euros in sales price. The sensitivity that we did conduct used variables for the discount rate and for the year-over-year sales growth. With the discount rate, we looked between 10 and 14% to use a 30% weighting on that side, and then a 70% weighting on this side for the year-over-year sales growth, just because we do believe the sales of the Audi vehicle, in particular, as it's a 1-to-1 ratio of the exhaust pipe to the vehicle, is going to have a little bit more weighting in terms of the entire sensitivity with the NPV that would equate to, as I mentioned previously, the 1.49 million euros in 5 years. In terms of the carbon emissions in the 5 year, just to give you a sense of what the savings would look like there, you see the green is the emissions saved and the red is the previous emissions line there. So the new emissions would just be that small blue line, and as you can see, it's quite a large degree of difference there, just around 89% savings per vehicle annually, which is actually in total a collective 437,000 tons, which means 93,000 vehicles off the road annually that would be saved over 5 years in the length of this project. A very realizable and tangible solution to the problem that we have at hand. And now Megan is going to jump into the nuts and bolts about how all of this works.
So, how will the supply chain look like? First of all, there'll be the suppliers, as Nick was mentioning. We'll need to be purchasing the MOF granules, the steel exhaust tips, as well as the ceramic pipe coating. Then we'll move into the manufacturing, where this will all mix together to become a product. And finally selling that to customers such as Volkswagen Group. We'll be focusing primarily on the manufacturing portion of this. The process will look something like this. We'll have our exhaust tips stored in the corner, and the process for the coating will be done along the middle, with the application stage at the very end and the ending stage in the other corner. This design has minimized footsteps to optimize our supply chain efficiency in the plant, as well as being able to put the application stage off to the side where we will need to have a special area for fumigation and cleanliness in order to make sure it's applied in a correct manner and not have any defaults with the materials. Our marketing plan has 3 steps. It will be first to educate, then to reach, and then to engage our customers. Overall, we want to foster key relationships and outreach methods by promoting climate change awareness. In our educate section, we'll be focusing a lot on corporate transparency. Since we're a green company, we want everything to revolve around our values in order to make a sustainable difference in the climate change global issue. We'll also be doing our reach through targeting companies who align with these values, as well as sponsoring climate change events. In our Engage program, we'll be looking for third-party support who are green companies, really bringing in that green throughout the entire supply chain, such as eco-labels, who are making environmentally friendly packaging and labeling. And finally, being an environmentally product declaration, going through the government channels to be declared as an environmentally friendly product. Our implementation plan has 3 stages. The short term is development. In this stage, we'll be primarily finalizing our design, establishing our key partners, building and testing our prototype, and then at the end, launching our pilot test. In the second stage is connecting. Again, we'll be connecting with more partners to run a full-scale implementation of the exhaust tip, as well as launching our marketing strategies, continuing to grow our climate base. And then at the end, we'd like to, of this middle term, we would like to further look into industry where this can be applied other than just exhaust tips of automobiles. Our third stage is long-term scaling. We'll be rolling out those ideas for the implementation of non-automobile products using MOF, as well as further streamlining our processes in order to maximize our efficiency through both the product and the business. And now Nick will tell you about some of the risks and mitigations we have come up with.
Thanks, Megan. So just like when it comes to every manufacturing plant, we have to make sure all cogs in the process rotate. If one is faulty, the whole system breaks apart and doesn't move. So we looked into some risks that come with that. So first of all, we might not be able to find a partner or customers with that. So we want to talk to some other manufacturers, not just the Volkswagen group. We want to branch out, and even if there's no one in the car industry, we can talk to the motorcycle industry, or we can talk to the big machinery manufacturers, such as CAT. The outcomes are really increase the brand awareness and have the partner availability. Even if we have partners for right now, we want to make sure we have something sustainable for the future so we can expand and really make sure we can save those greenhouse gas emissions. Second of all, we might have some problems with MOF and coating applications. So when it comes to the mixing process, this hasn't been done before. This is a new technology, less than a year old. But when we mitigate this, we want to closely collaborate with both suppliers. So we'll be a huge partner for both of them. So we want to bring them into our factory and make sure they can look at the processes and make sure we can have the most usable solution that really works for everyone. And third of all, there might be a lack of efficiency. So we've seen that right now that there's about 89% decrease in greenhouse gas emissions. But because this hasn't been done in a large scale in a commercial setting, there might be some problems. But this is exactly why we're doing the prototype testing, the piloting and the variety testing. There's different varieties of MOH, there's different cars, there's different coatings that we can use, and we want to make sure that this, when it gets rolled out, that it's done like we want it to be done and our clients are happy. So what we've done today, we want to see an impactful change will help generations and cut greenhouse gas emissions. It's a tangible solution that's not only realizable, but also highly scalable, not just to this industry, but worldwide. And it's innovative, something that hasn't been done before, but it really has a lot of potential out there. It's a fast growing market, and really want to see, we can see the future potential for this are immense. So like we said before, we're not only fixing the symptoms of a problem, we're going deep into these problems and seeing why this happens, why the droughts, why the changes happen, and we're fixing the underlying issue. By decreasing the greenhouse gas emissions with Eccc, we can really show the tangible benefit and scalable solution for worldwide problems. Thank you.
Okay, and reset this timer.
Quick question before I ask any wrong questions. Who are we in the case?
Yes.
Does it say?
It doesn't-
Yes.
No, that never really does.
Oh.
That's the weird
Okay, we're
part.
just gonna pretend this is a 10-minute clock.
No problem.
Yeah, go ahead.
Yep.
Well, you can go ahead if you want.
Tell me a little bit more about the storage and sort of the capacity. How does that work? What happens once sort of the storage gets filled, etc.?
Yeah.
What do I do as a
For sure.
customer?
Thank you. So actually, the 1 gram of this moth has approximately the surface area of 7,000 meters squared, possible kind of space for the carbon dioxide to enter. So we kind of approximated that as being, that's longer than the lifetime of a car typically. So we looked at that and we saw that it would be okay, just based off of the average lifetime of a car, that they wouldn't reach saturation point before then.
So, and then what happens in terms of when I dispose of the car? What happens in disposal of the exhaust system?
Definitely. So we looked into some of those systems, especially partnering with some of the companies right now that are looking to take carbon in its material form, change it into more of a liquid form. So in the future, in compliance with some of the changes that we're seeing in the environment, where you're seeing that liquefied carbon be taken into a potential fuel source, we realize that the economy and the environment right now really isn't ready for that change, but once it is implementable, there's the potential for this unit to be taken and to be materialized into that liquid form to be seen as a potential fuel source in the future.
Is there any way that this could be applied to not only new cars, but cars that are already on the market, or is the technology not there yet?
Yeah, for sure, this could be done. We want to focus on new cars just because with the prototyping it's a lot easier and just making this within our factory. But there is a possibility of really creating like a can spray that customers can go buy it and then apply it by themselves inside their piping. It is a bit of a harder process. They can do it by themselves or go to the nearest mechanic and do it for them. But that is a huge possibility for sure.
What do you see being the value add for these companies to start giving you, like partnering so heavily with you, because you talk about how like crucial these partnerships are going to be because this technology is brand new and this like the mixing it. Why are they looking to do this?
Definitely. So as a company, we're in the business to change the world. We want to see the change that we're looking to implement into the environment, into the economy, into an actual scalable, tangible solution. We focus a lot on tangibility because we see this problem as being something that we can fix, maybe in a small case scenario right now, but we want to see the implication of that being able to expand it and scale upward, and you can't do that unless somebody tries, unless somebody attempts to take those suppliers, utilizes them to work together, and to create a product that truly is going to make an impact.
Thanks.
In your financials, when you say per unit, is that per exhaust?
That is per exhaust, yes.
Okay, is there any way to lower that cost with the mass, because Volkswagen would be doing mass amounts of cars with that, and for
16 or something?
$116, is there any way that that could be scaled to be lower for the company?
So right now the current price that we did come up with is actually $26 below the industry average for what an exhaust pipe does cost, and that's why we felt that this would actually already be an advantage for Volkswagen. And as Meg did talk about, in our second stage of our implementation plan, we would work closely with them to provide a solution. Because there are such immense savings in terms of carbon right now, we feel that this price is extremely justified in the market right now.
Thank you.
How do you apply this to an industry like aerospace, where we've got huge CO2 problems?
It goes hand in hand with the scaling of our implementation plan. We're going to be doing a lot of research, connecting with partners that align with the values that we have with this global trend of climate change in order to figure out which parts of their systems would be most effective for implementing. And that'll change customer dependent from aerospace over to oil and gas service companies, automobiles. So really working hand in hand with them to optimize it.
After year one, we had our year one cost outline. What is it looking like for the years after that?
I'll just put you on speakerphone. That's okay.
So sorry, after year one?
Yes.
Yeah, so in terms of your costs, if you could go back to the, yeah. So you can see our miscellaneous and even our infrastructure costs, they're going to be X'd out here, where you're going to see a lot of the gain on that net income there that's balanced out after your taxes, which are just hovering around that 15% mark there. But I hope that answers your question.
Yeah,
That's why
thank
you
you.
see the scale there. So.
Thank you.
Oh, why are you looking at me?
I have a question.
Oh, go ahead,
Someone
Kenya.
ask a question.
Sorry, I missed a bit, so
That's okay.
this might be repetitive, but Yeah, my question is, so you guys talked about the 6 kind of issues at the start, and I appreciate you kind of drilling down, but can you describe to me more why you're focusing specifically on cars and why you believe this is the best solution for the growing climate change problem?
For sure, yeah, because like I said, cars are the largest contributors to the greenhouse gas emissions. They're over 25% of that space, and the industry is really aching for something to be changed. There's a lot of big disruptions happening and new players coming in, and if this gets implemented, we can see a phase out of basically greenhouse gas emissions for internal combustion engine cars. They could be again competitive with electric vehicles such as Tesla and other competitors moving into that space.
Okay, great, thanks.
Attaching on to that, to see your impact on this big global issue, do you have any KPIs you're looking at as far as your company?
Yes. So will be some of the KPIs will be looked at during a pilot test, especially to see if we're actually making change. We will be doing that through our testing, so being able to see the normal amount of CO2 released in a vehicle using tracking processes and moving that into what is released in our vehicle and under different operating conditions. So that'll be the primary test, is figuring out how much we're actually saving with the different methods we're using. And then as well as just financial metrics in order to make sure that we are still a sustainable company in itself. We don't want to make a large amount of profit because, as we've iterated, our goal here is to really make an impact for climate change, but we do want to be able to function as a company.
So how do you make sure you get the environmental movement on board with this? What's that key message piece with them?
So one of the main reasons we decided in our implementation phase to partner with Volkswagen was due to all the negative publicity that they've experienced in their market specifically. When you want to tackle automobiles, why not go after one of the companies right now in the world that produces the most amount of cars? At 10.4 million vehicles, their reach is immense, and not only does that possibly allow our product to be publicized and spoken of in the market, it allows customers in the market to purchase automobiles to recognize what our product is doing for Volkswagen vehicles in particular. That's going to allow customers to see the change that we're looking to implement into the world, and it's going to start the conversation about environmental awareness and about environmental sustainability that's going to possibly push our product into other streams of vehicles as well.
I understand this is a new product on the market and it's new to be put with the exhaust, and I really like the idea and where you're going with this. What testing has been done in the past to lead you to believe that this is like a viable solution?
So there's been a lot of testing around the world. Major universities have been doing that. MIT, Caltech has been working with problems like this. It hasn't been massively commercialized like we said, and if we do this and we work with our suppliers, really show them this will be their first large proof of concept, that this really works in a grander scale, and this will really help us as a company and all of our suppliers and customers.
So talk to me a little bit about, you ran discount rates, I think, from 10 or something to 16%.
Yeah, sure. Yeah, so we looked at a best, a worst, and a base case scenario. In terms of our base case, we did look at discount rates around 12%. That's right in the middle, where as the discount rate does increase, that does increase the riskiness of the product. In the automobile industry specifically, we took an average of what is currently available in the industry, looking at the WACC actually of Volkswagen, just to get more specific because we did want to narrow things down into that segment. And that coupled with our sales as well, where you do see the increase of between 5, 8, and 11%, with the highest value at that 11%, because obviously more sales is more money. We did look at the more sales alongside of the better discount rate to give you that best case scenario, because we wanted to give you an actual tangible idea of what could happen in the market for you. So.
Time for one more.
Try to think of an engineering one, I'm so sorry.
I know.
I can show you the.
Yeah.
Yeah.
So that's our build.
All right. Well,
Okay, that was good.
That was good.
Mm-hmm.
Good job, guys.
Thank you.
Thanks.